For the last part of this chapter, we are going to solve equations using trigonometric functions and identities. So first of all, we have to remember all of this is going to go back to the unit circle, okay? But what, that is so pretty. What do we know about the circle? It goes on and on and on and on. Okay, so we can go through one lap where I would start here and go to 2 pi. And I can find all the solutions in that one lap. Or I could find all of the solutions, which would be an infinite number. So the thing to remember in this one is, first of all, look at your domain, because it's either going to say find all of them, or it's going to say, find it from 0 to 2 pi, which would be one lap. Okay, so notice what your domain is. And then the second thing is going to be, look at the period of the function. So the period of the function is how often does it repeat, or how far do you have to go before everything starts repeating. So remember, for sine and cosecant and cosine and secant, your period is 2 pi. So I have to go through one complete lap of the circle. For tangent and cotangent, your period is 1 pi. So I only have to go through half of the unit circle before it starts repeating itself. Okay, so we're just going to dive in. The first couple are just going to be, does this work, does this not? So it's back to algebra, basically. So this one says the cosine of x is root 2 over 2. If x is pi over 4, does that satisfy the equation? So, well, I don't know. So let's shove in a pi over 4 here. And then, so here's the question. What's the cosine of pi over 4? Is it root 2 over 2? Yes, it is. Therefore, this is a solution of the equation. Okay, so let's do it again. I've got the cosine of x equals the sine of 3x, and I'm trying to test to see, does pi over 4 work? So I've got the cosine of just x, which is pi over 4, equals the sine of 3 times x, which is going to be 3 pi over 4. Okay, so what's the cosine of pi over 4? Cosine of pi over 4 is root 2 over 2. What is the sine of 3 pi over 4? The sine of 3 pi over 4 is, guess what? Root 2 over 2. So those two substitutions worked. So we say, yes, it is a solution of the equation. So now we have find all solutions of the equation, and it's not restricting us. And so this is where the unit circle comes in. So I'm going to write the problem first. It says, would you please solve, or give me all angle measures that solve this? So find all solutions. So what we are trying to find is, where does sine equal root 3 over 2? So the first thing I want to do is just restrict myself to one lap of the unit circle. Okay, so where does sine equal a positive root 3 over 2? The first place that happens is going to be at pi over 3. Okay, so what's the sine of pi over 3? It's root 3 over 2. Where's the next place that happens in one lap of the unit circle? And that's going to be at 2 pi over 3. Okay, and it does not happen again until I start in an additional lap. So I found the two places that this happens in one lap of the unit circle. So now you need to tell me what the period of the function is. So I need to do multiples of pi over 3 based on the period of the function. So what does that mean? I could say plus 2 pi. Okay, I could say plus 4 pi, plus 6 pi, plus all of these. So I'm going to use n as an arbitrary integer. And an arbitrary integer means I just pick it at random. Okay, there's really no rhyme or reason behind why I chose it. So arbitrary integer. And so basically you're going to say, well, 0 is an integer. So if I substitute in 0 for n, then 2 pi times 0 is 0. So pi over 3 plus 0 is pi over 3. Does that work? Yes, it does. Oh, let's grab another integer. So if I grab a negative 6, so 2 pi times negative 6 is negative 12 pi's. So pi over 3 minus 12 pi's, which is 6 laps of the unit circle, will land me at root 3 over 2. Okay, so you're going to use n for this integer. And so that's what we need to realize, is that if I'm working in terms of tangent or cotangent, then I'm not going to use 2 pi's times n. I'm going to use 1 pi times n. Otherwise, it's 2 pi n. So this is the other place it happens in one lap. So I've got 2 pi n. So those are your two generalized solutions for where sine of x equals a ratio of root 3 over 2. Okay? So that's why it says use pi as needed. Use an expression using n as the variable. Use integers or fractions for any numbers. Use a comma to separate answers. So this is your answer. Okay? Find the places within one lap and then acknowledge the period of the function times n. Okay? So let's do another one. We have find all solutions of the tangent of x equals 1. So if I want to find all solutions, that means my domain is not restricted. I'm going to find every place under the sun where this thing works. Okay, so first of all, where in one lap of the unit circle does tangent have a ratio of 1? And that's going to be at pi over 4. Okay, the next place it happens is going to be at 5 pi over 4, which is in quadrant 3. But stop the world, because the period of the function is pi. Okay, so think about it this way. For tangent, it's got a ratio of 1 here, and then if I add pi to it, it's going to have a ratio of 1. If I add pi to it, it's going to have a ratio of 1. Okay, so this time, I only need to find the one place that it happens, because the period is at half of the unit circle. And then my generalized solutions are the period times n. Okay, so that's what we're working with. So that is your answer, pi over 4 plus pi n. All right, so let's do another one. I'm trying to do this video in 2 sections. So I've got the cosine of x equals a negative 1/2. So cosine x equals negative 1/2. So I got 2 questions. What's the period? It's 2 pi or 1 full lap. So there's going to be 2 places where this works. Okay, so where does cosine equal a negative 1/2? Cosine will equal a negative 1/2 at 2 pi over 3. Cosine will equal a negative 1/2 at, I'm trying to remember this crap off the top of my head, 4 pi over 3, sorry. And those are the 2 places in one lap. Okay, now acknowledge the fact that our period is 2 pi and take integer multiples of it. Okay, so this is where you've got the first place it's going to happen. This is the second place it's going to happen. It'll happen twice because it's within one lap. 1 full lap of the circle, and then plus multiples of 2 pi plus multiples of 2 pi. All right, so let's find another one. I've got cosine of 2 theta equals root 3 over 2. So cosine of 2 theta equals root 3 over 2. And this time, I notice that I'm restricted to 1 lap of the unit circle. So I'm not finding every solution. That's a 2 pi. Stop that. All right, so from 0 to 2 pi. All right, so I'm staying within 1 lap. And what I want to do is, the second thing I notice is, holy cow, I got a multiple here. I will not necessarily go straight to my identities. Okay, I've got a single trig function here, so I can manhandle this. So our strategy is going to be the same. I want to find all the places where cosine will give me a root 3 over 2. So right now, the first place that cosine will give me a root 3 over 2 is going to be at pi over 6. Okay. The second place in 1 lap of the unit circle that cosine will give me a ratio of root 3 over 2 is going to be at 11 pi over 6. That is within 1 lap. Okay. I'm going to, and you don't know why yet, I'm going to go ahead and find the next 2 places. So even though I'm restricted within 1 lap of the unit circle, I'm going to find 2 more. So what is 11 pi? Oh, sorry, I just lied. What is 1 pi over 6 plus a lap? So 1 pi over 6 plus 12 pi's over 6 is 13 pi's over 6. So all I did was add 2 pi to this. And then what is an additional lap from here? So 11 pi's over 6 plus 12 pi's over 6 is 23 pi's over 6. So I'm kind of sort of floundering until I get the hang of what's going on. So here's what I know. If theta equals pi over 6, that's where cosine equals root 3 over 2. If theta is 11 pi over 6, that'll work. If theta is 13 pi over 6, if theta is 23 pi over 6. Here's the issue. I'm not dealing with a single theta. I'm dealing with 2 thetas. Okay, so I've set up the whole thing, and now I just need to solve for theta. So I'm going to divide everything by 2, and then see where I'm at. So if I divide everything by 2, pi over 6 over 2 is pi over 12. 11 pi over 6 over 2 is 11 pi over 12. Okay, 13 pi's over 6 over 2 is 13 pi's over 12. 23 pi's over 6 over 2 is 23 pi's over 12. And if you'll notice, 24 pi over 12 would reduce to 2 pi. So because I have a multiple here, that means I need to recognize that I'm adjusting how the frequency of this curve. And I feel like I'm speaking a foreign language. Anyway, so if you have a multiple here, just go ahead and find 2 or 3 more rounds of the unit circle. You may not need them, but now I'm within 1 lap of the unit circle, and there are 4 places where I could substitute this in to get a ratio of root 3 over 2. So again, if I shove in a pi over 12, 2 times pi over 12 is going to be the same thing as pi over 6. Okay, so you're just finding those multiples that work. Okay, so let's try another one. I have the tangent of x over 3 equals 1. So the tangent of x over 3 needs to be 1. And am I restricted? I'm restricted within 1 lap of the unit circle. So my restriction is from 0 to 2 pi. So ignore this. Tell me first of all, where does tangent have a ratio of 1? Okay, tangent has a ratio of 1 at pi over 4, at 5 pi over 4. So that's 1 lap of the unit circle. So a full lap will be 8 pi's over 4. So take this one. So give me 9 pi's over 4. Because 8 pi's over 4 plus 1 pi. 8 pi's over 4 will give me 13 pi's over 4. So I'm just giving some stuff to work with. I may not need it. I may need it. I don't know. Okay, so that's if my angle measure were these. I would get a ratio of 1. But that's not the angle measure I'm working with. I'm working with x over 3. So how do I resolve that? If I want to solve for x, I would multiply everything by 3. And then just take the ones that land me in this restriction. So multiply by 3. So that gives me 3 times x over 3 gives me x. So 3 times this gives me 3 pi over 4. I'm within 1 lap, so he's good. Multiply this by 3, I get 15 pi's over 4. Well, 8 pi's over 4 is 1 lap. So 13 pi's over 4 is generated there, but 8 pi's over 4 is 1 lap, so that took me too far. There is only one angle measure that this will work for, okay, that will land me within 1 lap of the unit circle. So you have a single answer, and that answer is 3 pi over 4, okay? Let's go some more. Trying to do the ones that don't need that. All right, so I have, how much time do I have? I do not have enough time. All right, so we're going to pick up with number 8. We're going to pick, actually, okay, yeah, we'll just pick up with number 8. All right.